Hello, we are going to be talking about chapter 9. We are going to complete the questions from the final review. We will start with the Word file. So I'm going to open up that file. Okay. Here, question 41 in section 4, chapter 9. Determine if the series is to the right converges or divergence. Series to the right means this is the series that they're interested in. Give reasons for your answer. Choose the correct answer below. If you would see, they use the limit comparison test for this series. They compare it with 1 over n. In C, they compare it with 1 over 5 to the n. In D, they compare with 1 over n. They get some results. I want to show you a similar question to this one, and I'll tell you how it is done, and you're going to understand. You can apply this to this question easily. Another version of this question is shown up here. The series has a n is equal to 2 to the n minus n times 2 to the n, which is similar to this. In this case, this is 5 to the n minus 3n over n 5 to the n. Okay, and the question is the same. Determine whether the series is convergent or divergent. We compare the series with this series, which is the harmonic series, and harmonic series is divergent, as you all know, and we take the limit of an over 1 over n. When you do that, we have 1 over n here and we have n here. They cancel each other, and we have 2 to the n minus n over 2 to the n left. And as n goes to infinity, this is going to go to infinity over infinity. We apply L'Hopital's rule once. The derivative of this is going to be 2 to the n ln 2 minus the derivative of this is 1 over the derivative of 2 to the n is this. And then let's evaluate that limit n goes to infinity. This is infinity over infinity again. Okay, so one more time we apply the L'Hopital's rule, and again take the derivative of this, you get 2 to the n, but we have one more ln 2, so we square it, and here 2 to the n ln 2 squared. As you would see, these two are the same. The limit is going to be 1. This would mean this series and the series made up of with this an, they act the same. So since harmonic series is divergent, then the series made up of using this an is divergent, and that's it. So in this case, we are going to apply this to this example in our sample test, and we are going to get that this series is going to act like the harmonic series, and since harmonic series diverges, it's going to diverge. So the answer is A. Look, this is A and this is B, and the limit is going to be 1. Since harmonic series is divergent, this series is divergent as well. Next, we are going to solve another example in chapter 9. The question is as follows. Chapter 9, section 5, question 61. Does the following series converge or diverge? Give reasons for your answer. This is A and this is the series, and as you will see in the answers, we want to check the root test or nth term test to decide whether this series is divergent or convergent. Nth term test, you know, you will get the limit of this if the limit greater than or equal to 1, then this is the divergence and term test. It's gonna diverge. And we have the root test we can also apply. Now I'm going to show you another example which is similar to this, okay? And you can really if you understand that, you're going to be able to do it on your own. And consider an, which is given as n to the n over 2 to the n squared. Here an is n to the n over 20 to the n squared. So if it is so in our sample question, it is 2 to the n squared. So we look at the the root test. Nth root test, we take the nth root of this an absolute value. Okay, and if you take the nth root of that term, nth root of n to the n is n, nth root of 2 to the n squared is 2 to the n, because it's n squared over n, gives you 2 to the n. And let's take the limit. This is infinity over infinity. Let's apply L'Hopital's rule once. 1 over 2 to the n ln 2. And this thing is, as n goes to infinity, this is 1 over infinity, which is 0. And this is less than 1. The nth root test says if you take the nth root, and if it is less than 1, then the series is convergent. So we can apply the same thing to here. Since the an's are very similar, we are going to get the same type of answer. Instead of 2, we are going to get 20. Okay, so we are going to say by nth root it's convergent, which is the answer is C. The series converges because the limit used in the root test is 0. Okay. Okay, this example, on the other hand, chapter 9, section 6, question 63. Use any method to determine whether the series converges or diverges. Give reasons for your answers. And this is the series n1 to infinity n to the negative 3 over square root of 17. And we are gonna, let's get the question, the choices we have. They talk about geometric series, they talk about ratio test, they talk about alternating series, they talk about the P series. Okay, so which one we should start with? Here's a similar question. Okay, this is a similar question's answer actually. In this case, instead of negative 3 over square root of 17, we have negative 2 over square root of 5. When we have a series like that, this is the P, we just take the P as 2 over square root of 5. It is less than 1. Since this is less than 1, it's a divergent series by P series test. Right, let's go back to our question. What is the P here? N1 to infinity 1 over n to the 3 over square root of 17. Here P is 3 over square root of 17. Square root of 17 is around 4, bigger than 4. So we have 3 over 4 as close to 3 over 4 as our P. P is definitely less than 1. So we are going to say it diverges by this P series test. The answer to this question is D because of that. Okay. Okay, next question is chapter 9, section 7, question 54. You are given a series as follows, but this is Taylor series opened up around 3. This series is actually equal to 2 over x minus 1. It's equal to this function in this radius of convergence. So outside of this interval, they are not equal. but inside this interval, for every x in this interval, this series on the left is the same as the function on the right. Okay, and the question is, if you integrate the series below term by term, what new series do you get? And so we are going to integrate this series term by term and see what we get. And then next question, for what values of x does the new series converge, and what is another name for the sum, and what's the, yeah. So let's look at the choices, the answers here. So we are going to choose one of them as the integral of the given series. And for what values of x does the new series converge, we are going to enter it here. Okay, now here is the solution to that question. Okay, first of all, f of x, the series is 1 minus 1 over 2 x minus 3 plus 1 over 4 x minus 3 squared plus da da da, and this is equal to 2 over x minus 1 in the interval of convergence 1 to 5. Okay, if you look in here, they're asking about, let me correct this. Okay, they're asking about, they're asking about the integral of this f. We integrate this term by term. The integral of a1 is x. The integral of x minus 3 is x minus 3 squared over 2 factorial, but we have 2 here, it makes 4. Don't forget the negative sign. The integral of this is x minus 3 cubed over 3, but we have 4 here, 3 times 4 makes 12. And negative 1 over 2 to the n, the integral of this is x minus 3, increase the power by 1, divide by it, and we have this. Okay, next they are asking, after you integrate you get this series, how about the interval of convergence? Did it change? Is it 1 to 5 or is it more than that? So we have to check the endpoints, because the endpoints may differ. The inside of the interval is going to stay the same, but the end of the intervals may be included extra. So we check x is equal to 1 first. At x is equal to 1, we put 1 to this. So this is going to be 1 minus negative 2 squared over 4, negative 2 cubed over 12, etc. So if you look at it carefully, you're going to see at x is equal to 1, this is negative 2 to the n plus 1, okay, negative 2 to the n, and there's another negative 2 to the n, they cancel, negative 2 to the 1, so we have negative 2 left, and n plus 1 is left. That's what you get here. Now this is a harmonic series, so it is divergent, so x is equal to 1 cannot be included in the interval of convergence. How about x is equal to 5? X is equal to 5, we go back in here and put it in. 5 minus 2 squared over 4, 2 cubed over 3, 2 to the n plus 1 over n plus 1, negative 1 over 2, 2 to the n. Here we have negative 1 over 2 to the n is gonna stay, but 2 to the n's are gonna cancel each other. We have 2 left, negative 1 to the n times 2 over n plus 1. So this is a alternating series. Okay, it is convergent. We talked about this before. So at x is equal to 5, it is convergence. This is going to tell us that the interval of convergence is 1 to 5, 5 is included. And how about the sum? the sum is, so you have to integrate this 2 over x minus 1 as well, because you're integrating this to get that. So you have to integrate this to get the value. And if you integrate that, you get 2 times ln x minus 1 plus c. And c can be found by plugging x is equal to 3, because when you plug in x is equal to 3, okay, x is equal to 3, this vanishes, and 3 stays the same, alright, and it's equal to this plus c. So from here, okay, of course we are going to put x is equal to 3, so we have 2 ln 2, c is equal to 3 minus ln 4, we got that, and this is the value, okay? Okay, so this is the question, excuse me. Okay, chapter 9, section 8, the question is as follows. I have to move a little bit more down here. Sorry. Okay, this is the question actually. Okay, let me get rid of that. Okay, find the Maclaurin series of f of x is equal to 4 cosine negative x. That's the question, and the answer is given here. So I'm gonna show you the solution of something where f is equal to 7 times cosine negative x. They agree except the number in the front. So 7 cosine negative x. We know that cosine is an even function, so cosine negative x is the same as cosine x. And we also know how to express cosine x as a power series, which is negative 1 to the n x to the 2n over 2n factorial. So 7 in the front, we just distribute this over, we expanded it, and we said this is the Maclaurin series for f of x is equal to 7 cosine negative x. Alright, and now let's move on. Chapter 9, section 9, and here's a question, question 25. Use power series operations to find the Taylor series at x is equal to 0 for x to the 5 arctangent x squared. Okay, that's the question. And these are a, b, c, d that are given. Okay, that's it, I guess, right? Yeah. And what is the answer? The answer is D, and I'm going to explain why this is so. But I'm going to solve a problem that's almost the same, except instead of x to the 5, I have x here. Okay, so the same question, they say use the power series operations to find the Taylor series at x is equal to 0 for x times arctangent x squared. That's the question, okay? We first write what arctangent is in terms of the power series. It's x minus x cubed over 3 plus x to the 5 over 5 minus x to the 7 over 7. It's alternating, and the powers are odd numbers, 1, 3, 5, 7. Okay, and then x times arctangent x squared means you just multiply this series with x. If you multiply it with x, you get x cubed minus x to the 7 over 3, etc. And you can write it in compact form, but there's a little bit typo here, but it's enough just for you to write it in like this. Okay, that's the end of the question. And chapter 9, section 10, question 39. Use series to evaluate the limit. Sometimes we use series to evaluate the limit. It makes it easier. Okay, so in this question they ask find the limit as x approaches to 0 sine 4x squared over 1 minus cosine 6x. I want to show this in just a little bit varied problem up here. So they are asking us to find limit as x approaches to 0 sine 3x squared over 1 minus cosine 2x. Sine 3x squared we know, because we know sine x in power series, okay? It is x minus x squared, x minus x cubed over 3 factorial plus x to the fifth over 5 factorial, etc. This is sine x. But wherever we see x, we put 3x squared and we get this series. Similarly, for cosine, we know the formula for cosine 2x. Wherever we see x, we just substitute that by 2x and multiply by -1 and add 1 to it, you get such a series. And then take these two series and put it in the limit. This is this series and this one is this series. And look at that. I have x squared here, factored this out. I have x squared here, factor that out. Then I have this left on top and in the bottom. And now you can evaluate x goes to 0. Let x to be 0 here, you get 3 on top. Let x equals to 0 here, you get 2 in the bottom. And 3 over 2 is the answer. Okay? For this other problem, on the other hand, we have the answer is 2 over 9. You can try it out at home. Okay?